Hi, I will present distributed black box attack against image classification cloud services. Black box attack can fool image classification models without access to model details. Our research intends to investigate if black box attacks have become a real threat against image classification models deployed on cloud servers. It is no more secret that deep learning models are vulnerable to adversarial attacks. We can generate human unperceivable perturbations to fool image classification models. Existing adversarial attacks consist of white box attacks and black box attacks. White box attacks have full access to model details and are fast and efficient. They can attack deep learning models in real time. On the other side, black box attacks do not require access to model structure and weights, but they rely on queries and are slow. For black box attacks, prior research has primarily focused on increasing the attack success rate and reducing the number of queries. However, another crucial factor is the time required to perform the attack. Black box attacks can be a real threat if they are both time efficient and can achieve a high success rate. So we investigate if it is possible to reduce the total attack time. Well, how can we accelerate black box attacks? Black box attacks rely on queries, which is time-consuming. Our experimental results demonstrate that sending out 10 queries concurrently takes roughly the same time as sending out one query, which means that we can accelerate black box attacks by sending out queries concurrently. The more queries we send, the less time each query takes in average. This is because modern cloud APIs are usually deployed behind a load balancer. The load balancer distributes the traffic across several servers. Thus, we can get query results of multiple concurrent requests simultaneously. Before introducing the cloud service we attack, we noticed that most prior research used local models to test black box attacks because sending queries to cloud services is slow, while querying a local model with GPU acceleration is much faster. However, testing black box attacks against local models could introduce several mistakes in the query process that gave their methods an unfair advantage. Say, for example, prior research usually resizes input images to be the same shape as the model input and then applies the perturbation, which means they assume we have access to the input shape of the model. Some methods outperformed the state of the art, partially because these mistakes gave them access to information that should not be assumed to be available in black box attacks. As a result, we initiate black box attacks directly against cloud services to avoid making similar mistakes, and we apply the perturbation directly to the original input image. Our experimental results demonstrate that attacking cloud APIs is more challenging than attacking local models. For local search and gradient estimation methods, attacking cloud APIs achieve less success rate than attacking local models. In our experiments, we limit the number of queries for each image to be at most 1,000, which is quite challenging. As a result, the baseline method only achieves a success rate of roughly 5%. Besides, attacking cloud APIs require more queries than attacking local models. For the baseline method, we do not see an evident increase because the attack success rate is relatively low. Most attacks consumes all the query budget. The cloud API we attack is Deep API, an image classification cloud service we open source for research on black box attacks. Here's a quick demo. We can upload images to the cloud server and receive image classification results. Say, for example, we can choose different datasets and different models. We support Cipher10 and ImageNet. As you can see here, it is recognized as a dog. Well, maybe we can try a different image. And this time, maybe we can try a cat. And we can choose VGG16 pre-trained on Cipher10. It is recognized as a cat. Well, besides uploading images from the website, we can also use the API to do image classification so that we can automate the query process to initiate black box attacks. To make the deployment of DBAPI easier, we provide a Docker image as well as a Python package which can be installed via pipe install DBAPI and start the server using a single command. Furthermore, we designed two general frameworks, horizontal and vertical distribution, that can be applied to existing black box attacks to reduce the total attack time. Horizontal distribution sends out concurrent queries across images at the same iteration, so we receive the query results for different images simultaneously and then move on to the next iteration. The benefit of using horizontal distribution is that we do not need to redesign the black box attacks. We only need to replace the original model queries with concurrent queries. After applying horizontal distribution, we can see that the total attack time is reduced by a factor of 5. The total time of attacking 100 images was reduced from over 20 hours to 4 hours. On the other side, vertical distribution sends out concurrent queries across iterations for the same image. For each image, we generate multiple adversarial perturbations and send out queries concurrently across iterations. For vertical distribution, we need to redesign the black box attacks to decouple the queries across iterations. In the research paper, we use both local search and gradient estimation methods as examples to illustrate how to redesign the algorithm to apply vertical distribution. After applying vertical distribution, besides reducing the attack time, both local search and gradient estimation methods achieve early successful attacks. The probability of the original predicted class drops faster. In conclusion, our research demonstrates that it is possible to exploit load balancing to accelerate online black box attacks against image cloud services, and we open source our image classification cloud service to facilitate future research on distributed black box attack to test if black box attacks have become a practical threat against machine learning models deployed on cloud servers. You can find the source code and the slides on this website. Thank you